Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Today we are going to discuss new topic. And in the first case, we have completed solid state, the first lectures, first chapter of 12th class. Now we are going to do solutions and colligative properties. That is dilute solutions and colligative properties. So in this chapter, what we are going to do? First, what is the introduction here? Solutions. A solution is a homogeneous mixture of two or more components. A solution is a homogeneous mixture of two or more, underline two or more. So when you are listening this class, just whatever the slides have been displayed on the board, you have to write in your classwork, then only it can be easy for you to understand. Otherwise, simply by listening, you will not get anything. So it's better to listen carefully and then write in the classwork and then solve the numericals and what are the concept-based questions are there. Then it will be easy for you. So without the lecture also, you can able to do it. So solutions are the homogeneous mixture of two or more components. So it has either two components or more than two components. In a binary solution are those which has only two components. One component is called solvent, which is present in large excess, which is in excess quantity, and the second component is solute. So always solvent is larger quantity and solute is smaller quantity. So in this chapter, we are going to learn more about binary solutions. So solutions are the homogeneous mixture of two or more components. In a binary solution, one component is solvent, which is in large excess, and the second component is solute. Next. Types of solutions. So solutions means you'll think only it is in liquid form. It is not correct. We have gaseous solution, liquid solution, and solid solution. So first types of solutions, gaseous solution. So in this, the solute is gas, first type of solution. Solute is gas and solvent is also gas. Means we have that is also called as solution. Solution means don't think it is only liquid, where some amount of solid or gas is dissolved in it. It can be gas and gas also. Means the solute is gas and solvent is also gas. Example, air is a mixture of oxygen and nitrogen, in which in air, oxygen and nitrogen is present. So nitrogen is solvent and oxygen is solute. So in this way, you will get the gas solvent. Next, liquid in gas. Liquid in gas. So gas is solvent, liquid in gas. So moisture in nitrogen gas. Moisture in nitrogen gas. That is also liquid in gas. Next, solid in gas. Camphor in nitrogen gas. Camphor in nitrogen gas. So all these three are gaseous solution because the solvent is gas. Next, liquid solution. What we can say what a liquid solution means, in which the solvent is liquid and solute can be gas, liquid, or solid. So that's why they are called as liquid solutions, which are present in large quantity. That name of that solution will get. For example, in the first case, if you see, all the solvents are gases. You can see in the first case, gaseous solution, all the solvents are gases, and solute can be gas, liquid, or solid. So examples also given to it. Same way, liquid solution. So it consisting of solvent, liquid, and if a gas is dissolved in liquid, it is called gas in liquid. Oxygen dissolved in water. This is an example. Even cool drinks also, it is an example of gas dissolved in liquid, because in cool drinks we have carbon dioxide gas is dissolved in the solution. Next, liquid, alcohol dissolved in water. Alcohol dissolved in water is called as liquid solution, and solid in dissolved in liquid, it is called sugar dissolved in water. It is called liquid solution. I hope it is clear now. Next, solid solution. Gas dissolved in solid. Hydrogen gas in palladium, it is called as occlusion, and hydrogen gas is being absorbed. Here absorption is taking place and on palladium surface. So this is called gas dissolved in solid. Next, liquid dissolved in solid, sodium amalgam. Sodium is a solid and amalgam is mercury liquid. So sodium amalgam, it forms a moisture like mixture. So it is called as sodium amalgam is mercury, Na plus Hg. Next, solid dissolved in solid. Copper dissolved in gold. Alloys. All alloys are nothing but solid solutions. All alloys are solid solutions. So copper dissolved in gold is called an alloy. So these are the different types of solution. I hope it is clear. Solution, we have three types of solutions: gaseous solution, liquid solution, solid solution. In gaseous solution, we have the solvent is mainly gas. Solvent is gas, and solute can be gas, liquid, or gas. But solvent is gas. In liquid solutions, solvent is liquid, and solutes can be gas, liquid, and solid, and it can be anything. Whereas in solid solution, the solvent is solid, and the solute can be gas, liquid, and solid. So all these examples is clear. Now we have got a clear idea about solutions. Next, first topic in this chapter is expressing concentration of solution. This topic is there in 11th class also, but in together 11th and 12th, it is very, very important. From this topic, you will get definitely a question for competitive exams, either JEE Mains or Advanced or NEET. So what is the way of expressing concentration of solution? Because a solution is best expressed in concentrations only, and concentration is a physical quantity in which describe the composition of solution. The concentration of solution can be expressed by several units. First one, mass percentage, that is weight by weight relationship. Second one, volume percentage. So we can express a solution and its concentration by using mass percentage, that is 15% weight by weight, 10% weight by weight of sodium carbonate, and so on. So similarly, volume percentage, volume by volume, that is 10% volume by volume of NaOH solution, like that. And mass volume percentage, mass volume is nothing but mass as well as weight by volume, that is also called as weight by volume percentage. And next we have parts per million. Next we have mole fraction. Next we have molarity and normality. Normality also it coming under molarity. I'm writing here normality also. In the sixth case only, molarity as well as normality also will come. Normality is denoted by capital N. Molarity is denoted by capital M. Molarity, normality. And the next way of expressing concentration of solution is molality. And interconversions of these is very, very important. So now coming to mass percentage, weight by weight percentage. It is a mass of solute present in grams, present in 100 grams of the solution. So mass of the component in the solution by total mass of the solution into 100. So mass percentage, you have to note down the formula. Mass percentage is equal to mass of the component of the solution, mass of the component of the solution by total mass of the solution into 100. Total mass into 100. So I hope it is clear. Next, example 1, based on this one question. Calculate the mass percentage of ethanol. Ethanol is C2H5OH. Ethanol formula is C2H5OH. Anyway, we don't require formula here. C2H5OH is called ethanol in a solution obtained by dissolving 50 grams of ethanol in 250 grams of water. So they have given mass of the composition, total mass into 100. So simply you can write 50. So mass percentage is equal to mass of the component. Mass percentage is equal to mass of the component of the solution, that is ethanol, 50 grams, 50 by 250. Total mass of the solution is 250 into 100. So by substituting this value, you'll get the answer. So you can calculate easily 1 by 5, that is 100 by 5, that is 20. So 20 is the mass percentage. So in 250 grams of water, 50 grams of ethanol is nothing but 20%. I hope it is clear now. So answer 20%. So mass of ethanol by mass of ethanol plus water, sorry. So here we have to take mass of ethanol plus water. So that should be at the mass of ethanol plus mass of water into 100. So that is 550 by 50 plus 250 into 100. 50 by 250 plus 250 into 100. That's why we got. So total mass is equal to 50 plus 250, it is equal to 300. So mass of ethanol 50 by 300 into 100. Then you'll get 16.67. It is clearly given. 50 by 3, it is 16.67. 667 or 16.67 directly. So it is clear now. Next question. Volume percentage. So it is the volume of the liquid in cubic centimeters. Cubic centimeters means milliliters. Present in 100 cubic centimeters of the solution. So cubic centimeters means present in 100 cubic centimeters of solution. So volume of the component by total volume of the solution into 100. So volume of the component means actual only solute, and volume of the solute plus volume of solvent. Total volume of solution means volume of solute plus volume of solvent into 100. So this is nothing but total volume of the solution. So you have to calculate volume percentage. Next, so how to give volume percentage of benzene and toluene in the solution? Benzene and toluene, they are given clearly all the values. 25 ml of benzene is mixed with 150 ml of toluene. So calculate the volume percentage of benzene and toluene in the solution. And for this, hint is also given directly. So volume percentage is equal to volume of the solute, that is 25 ml, because benzene is smaller quantity and toluene is 150 ml. It is, so benzene becomes solute and toluene becomes solvent because of excess quantity. So 25 ml by 25 plus 150, that is total volume solution, into 100. So straight away if you substitute this, you'll get the answer. I hope it is clear now. So 25 plus 150 is 175. 25 by 175 into 100. So if you solve this, you'll get the answer easily. Now I'm giving the answer for this. So 14.28 volume of benzene plus volume of toluene. So volume percentage of benzene is equal to 14.28 and the remaining is volume percentage of toluene. That is 100 minus 14.28, 85.72. Because they have asked volume percentage of benzene as well as toluene in the solution. So for toluene, 100 minus volume percentage of benzene, that is 14.28. So you'll get 85.72. So it is clear, I hope. Next question. Next, mass percentage or by volume percentage. Mass volume percentage. It is a mass of solute. Here weight by volume. Till now we have seen weight. Now we are seeing weight by volume. It is a mass of solute in grams dissolved in 100 cubic centimeters of the solution. 100 cubic centimeters. Here the units are important. Mass of solute is in grams and volume of solution is ml into 100. Suppose if they are given in grams and volume in liters, then we have to convert the given volume into milliliters. So that's why units are important for solving numericals, because in the examination they will try to change the units. So it is a mass of solute in grams dissolved in 100 cc centimeters of solution. So mass by volume percentage, it is another way of expressing concentration of solution. So it is another way of expressing concentration of solution. So mass percentage, mass of solute by volume of solution into 100. I hope it is clear now. Next example, calculate the mass of glucose that must be dissolved in 500 ml. Here they have given volume of the solution and 15% weight by volume solution. So here they have given mass percentage. So 15 is equal to, so I'm solving it directly. 15 is equal to, because they have given mass percentage, mass by volume percentage is equal to weight of mass of solute, that is X. We have to find mass of glucose, that is X, divided by volume of solution, that is 500 ml, 500 ml into 100. So X is equal to 15 into 500 by, so X is equal to 15 into 5, 75 grams. I hope it is clear now. So X is equal to 75 grams. So mass of solute by volume of solution into 100. So X value you get as 75 grams. That is mass of glucose. So they can give either to find mass or volume percentage, or they can also give us to find mass of the solute or volume of the solution. So it is clear now. Next way of expressing concentration of solution is parts per million, ppm. Usually this is given for medicines, because in medicines all the quantities of the ingredient, that is nothing but the solute or the solvent, whatever it is, all the substances in a medicine will be in very very minute particle. So that's why they'll express in terms of ppm. Even hard water also, as we discussed, hard water also will be expressed in terms of ppm. And ppm means it is very very lesser part, means in one part, in 1 million of the solution, 1 million part of the solution, one part of the solute is called parts per million. Simple words. Again, I'm repeating the words. In 1 million part of solution, that is 10 to the power of 6 parts of solution, only one part of solute is called as parts per million. So it is very, very less amount. So this unit is used to express the concentration of very dilute solution, very, very dilute solution. It is defined as the number of parts per mass of solute present in 1 million parts by mass of the solution. As I told you, number of parts by mass of solute present in 1 million parts of the by mass of the solution. So ppm is equal to mass of solute by mass of solution into 10 to the power 6. So mass of solute by mass of the total solution into 10 to the power 6. That is called ppm. Now let us see one problem based on parts per million. A sample of water contains 200 grams water. Total mass is 200 grams. Contains 16 10 to the power minus 4 grams of dissolved oxygen. Calculate the ppm concentration. So ppm is equal to mass of solute, that is mass of solute, that is 16 10 to the power minus 4 grams. Mass of solute, that is 16 10 to the power minus 4 grams, because it is dissolved in oxygen, by total mass of the solution, mass of solvent, that is 200 grams. Total mass, that is the mass of solvent, it is actually directly mass of solution, that is 200 grams into 100 into 10 to the power 6, sorry. So by solving this, you'll get the answer. I hope it is clear now. So mass of solution, that is total mass of the solution, is 200 grams, contains 16 10 to the power minus. So a sample of water 200 grams contains, so already it contains 16 10 to the power minus 4 grams. So total mass of the solution you have to take into 10 to the power 6. So after substituting this, you'll get ppms will be equal to 3. So number of ppms is 6 into 10 to the power minus 4 divided by mass of solution 200 into 10 to the power 6. If you solve, let us see now. So 200 means 2 into 10 to the power 2, 10 to the power 2, 10 to the power 6, 10 to the power 4, you'll get. I'm solving it. 2 into 10 to the power 2, 2 3 times. So 3 into 10 to the power 2. So here 10 to the power minus 4 remains. So 3 into 10 to the power minus 4, it is equal to, so 3. I hope it is clear now. So 3 ppms. So only 200 you have to take. You should not take 16 10 to the power minus 4 plus 200. Only 200 you have to take. Again, I'm writing here if you have any confusion. So ppm is equal to 16 10 to the power minus 4 grams, that is mass of solute, by total mass 200 grams. 2 into 10 to the power 2, I'm writing for understanding, into 10 to the power 6. So 10 to the power 4, 10 to the power 6, and 10 to the power 2. 10 to the power 2 going to numerator, 10 to the power minus 2. So it becomes 10 to the power 6 and 10 to the power 6. Both gets cancelled. 10 to the power minus 6 and 10 to the power 6. That's the same thing. So 2 is 3. So answer is 3. I hope it is clear now. Next question. Next way of expressing concentration of solution is mole fraction. So mole fraction, the mole fraction of a component is a ratio of number of moles of the component to the total number of moles of all components in the solution. Mole fraction of solute is number of moles. How to calculate number of moles given weight by molecular weight? Number of moles has been taken as given weight by molecular weight. And the number of moles of solute is also nothing but weight of solute by molecular weight of solute. And number of moles of solvent is weight of solute by molecular weight of solvent. So here I'm writing again on the side. So mole fraction is denoted by letter chi. It is X. It is nothing but chi will say. Mole fraction of solute is X of A is equal to N of A. That is number of moles of A by N of A plus N of B. That is total number of moles of solution. Where N of A is called number of moles of solute. N of B is called number of moles of solvent. And N of A plus N of B is equal to number of moles of solute plus solvent. So similarly, mole fraction of solvent is equal to N of B by N of A plus N of B. And how to calculate N of A, because in some questions they will not give N of A. So N of A is nothing but weight of solute by molecular weight of solute. Weight of solute by gram molecular weight of solute, or molecular weight of solute simply. Similarly, N of B is equal to weight of solvent by molecular weight of solvent. So, and already you know mole fraction of solute plus mole fraction of solvent is always equal to 1. Mole fraction of solute and mole fraction of solvent is always equal to 1. So these are the main formulas from mole fraction of component. So this is another way of expressing concentration of solution. So a solution can be best expressed in all these concentrations, that is mass percentage, volume percentage, mass by volume percentage, ppm, next mole fraction, next molarity, as well as molality. So I hope it is clear now. Now we'll see question based on mole fraction. Simple questions first I'm giving. Mole fraction to be continued as I already given you. So in a solution containing n components, the mole fraction is given by xi is equal to ni by n1 plus n2 plus and so on, sigma ni. This total number of moles of the solution. And always mole fraction of all the components in solution is equal to 1. So as we are discussing binary components, binary solutions, so only two components we have. So mole fraction of A plus mole fraction of B is equal to 1. So which I already given in the previous slide. So it is clear now. Next question based on mole fraction. A solution is formed by dissolving 234 grams of benzene. Here see 234 grams of benzene, underline, in 460 grams of toluene. So here 460 grams of toluene. So they have given directly mass. They have not given number of moles. They have given mass of solute and mass of solvent. That's why I told weight of solute or weight of solvent by or mass of solute or mass of solvent. Here benzene is formula is C6H6. Benzene formula is C6H6 and toluene formula is CH3 on C6H5CH3. Benzene formula is, because we should know the formula, because we have to compare number of moles first. So benzene formula is C6H6 and toluene formula is toluene formula is toluene formula is toluene formula is C6H5CH3. C6H5CH3. So we have benzene and toluene. Now from the benzene formula, we can find molecular mass of benzene, that is carbon is 12, 12 into 6, 12 into 6 plus 6, 6 into 1. 12 into 6 plus 6 into 1, which is coming around 78. 78, molecular weight of benzene is 78. Because hydrogen molecular mass is 1. Similarly for toluene, 12 into 6 plus 5 into 1 plus 12 into 1, because 1 carbon in the middle, plus 3 into 1. So it is equal to 12 6 is 72 plus 5 plus 12 plus 3. So 72 plus 5 plus 3, 80, 80 plus 12, 92. So total is 92. I hope this is clear now. Now, how to solve this problem? They are asking mole fraction of each component. First, we find mole fraction of A. That is, mole fraction of A is equal to N of A. First, we have to find. Since they have not given number of moles, we have to take N of A is equal to 234. Weight by molecular weight. That is 72. So 234 by 78. So 234 divided by 78 is equal to 3. So N of A is equal to 3. Similarly, 92, and here N of B is equal to 460 by 92. So weight of solute by molecular weight of solvent. So 460 divided by 92. So you get it as 5. N of B is equal to, similar N of B is equal to weight of solute, weight of solvent, that is 460 by molecular weight 92, it is equal to 5. Now first we have left hand side finding mole fraction of A is equal to N of A by N of A plus N of B, that is 3 by 3 plus 5. So it is 3 by 8. So 3 divided by 8, you'll get as 0.375. Similarly, mole fraction of B. Mole fraction of B, automatically if you get mole fraction of A, mole fraction of B is 1 minus 0.375. 1 minus 0.375. So straight away applying the formula. Now after that also you'll get 1 minus 0.375 means 0.625 you should get. Let us see, 5 by 8 it should be. 5 by 8 means 5 divided by 8, get it as 0.625. As I already told you, if you know mole fraction of A, mole fraction of B is not required to find. So 1 minus 0.375 should be 0.625. So I hope this is clear. In this way, you have to find first sum as it is first sum. That's why I have showed it clearly. Next question. So 0.375 and 0.65. So if you know only mole fraction of solute, so solvent, no need to find again because 1 minus 0.375 is 0.625. So 1 minus mole fraction of solute is called mole fraction of solvent. I hope it is clear now. Next question. So next concept, that is molarity as well as molarity. Small m, sorry, capital M for molarity and small m. So units of concentration next, molarity. So molarity means capital M. Molarity, R-I-T-Y. It is defined as a number of moles of solute dissolved in 1 liter of the solution. Number of moles of solute dissolved in 1 liter of the solution. So number of moles already you know how to find. That is mass of solute by molecular mass of solute and volume of solution in liters. If they are given volume of solution cc, we have to multiply with 1000. Otherwise, only volume of solution liters. So molarity is equal to final formula mass of solute by molecular mass of solute, because number of moles of solute, sometimes they will not give number of moles straight away. They will give mass of solute, and molecular mass of solute you can find out. So molecular mass of solute and volume of solution liters. That is cc. If they have given, you have to multiply with 1000. I hope this is clear. This is another way of expressing concentration of solution. So this is called molarity. Normality and molarity are same. Only thing here, for normality, instead of using molecular mass of solute, we use equivalent mass of solute. We'll use what? Equivalent mass of solute. So normality n, I am writing it separately. Normality n is equal to mass of solute. Instead of writing mass of solute, I'll write W. Okay, mass of solute divided by molecular mass of solute. You cannot write. Here we should write only equivalent mass of solute into volume of solution. Equivalent mass of solute into volume of solution liters. As I have taken volume of solution liters, no need to write 1000. I hope this is clear for you. So molarity and normality, small slight difference is there. That also we'll discuss in the coming session. Next, example 1. Calculate the molarity of a solution obtained by dissolving 10 grams of sodium hydroxide in 150 cc or 1500 cc of solution. They have given 1500 cc. So volume is given 1500 ml or 1500 cc, and solute mass of solute is given 10 grams. That is WA. Mass of solute W is given 10 grams. So they have not given number of moles. So first what you have to do, so molarity is equal to molecular mass of sodium hydroxide. Even if they don't give also, we know how to write, because sodium is 23, oxygen is 16, hydrogen is 1. By adding all these 6, you can get here molarity, capital M is equal to capital M is equal to weight of solute, that is 10 grams, by molecular mass of solute, that is 40, into volume of solution 1500 ml into 1000. So if you solve this, you will get the answer easily. 1500 cc is nothing but 1500 ml, both are same. 1000 we have to write because cc they have given. So straight away cutting 2 zeros and 3 zeros with 40. So it is 10 by 4 into 15. 4 15 4 is 60.
1 by 60.
1 by 60, which is equal to, you know the answer, 1 by 60, 0.016. Capital M. Capital M is important. So this is clear. 0.0166 or 167. It is okay. Next question. Next, expressing concentration of solution is molality. So what is molality? Molality of a solution is defined as the number of moles of solute dissolved in 1 kg of the solvent. So number of moles of solute already you know, weight mass of solute by mass of solute into mass of solvent, that is expressed in kgs. If they are expressed in grams, you have to multiply with 1000. Mass of solvent should be taken in gram, 1000 in grams. If they have given mass of solvent in grams, you have to multiply with 1000. And number of moles of solute. It is denoted by letter small m. Small m is not mentioned here. It is mentioned on the top. So molarity is denoted by letter small m. Small m is nothing but molal. Molal they'll say. For example, whatever the answer you got. So example for this molality, if you got 0.1, we'll say 0.1 molal. 0.1 molal. MOLAL. I'm writing it on the board. 0.1 molal. Molal. So in this way, you write molality. So we have considered all the types of concentration of solution. Next question based on molality. Calculate the molality of the solution obtained by dissolving 5 grams of acetic acid in 200 grams of benzene. So 5 grams of acetic acid. Acetic acid formula is CH3COOH. CH3COOH. Because you have to consider molecular mass also, because number of moles of solute by mass of solvent in grams into 1000. Mass of solvent is they have given. For benzene no need to require. So first find molecular weight of acetic acid. So it is 12 plus 3 plus 12 plus 16 plus 16 plus 1. After adding all this, so 12 plus 3, 15, 27, 27 plus 1, 28, 28 plus 16, 44, 44 plus 16, 60. So molecular mass of acetic acid is 60. Molecular weight of acetic acid is 60. Now by substituting this, how to calculate molality? Simple. So molality small m is equal to number of moles of solute, that is weight of solute, 5 grams, because they have given mass of solute is 5 grams, by molecular weight of solute 60 into 200, and here on the top into 1000. So if you solve this, you'll get the answer. So 0, 0 gets 0, 0, 1 more 0 for 60. So it is 5 by 12. So 5 by 12 becomes, you have to divide 5 with 12. I know it is easy. So 5 divided by 12 is equal to 0.416. Molar solution. Molar means small m. Here we should write small m, and in the previous one we have to write capital M, molarity. I hope this is clear for you. Next. So 0.416, 0.0416 exactly you'll get. Next question. Calculate the mole fraction of benzene in solution containing 30% mass by mass of tetrachloride carbon. Very, very important here. From mass percentage, they have given 30% by mass. Means mass percent means weight of weight. So calculate the mole fraction of the benzene solution. So total 30% means in that 30 grams is benzene, and by mass of carbon tetrachloride, 30 grams of CCl4 will be there, and remaining, so 100 grams of benzene solution total. So how to calculate mole fraction of benzene solution containing 30% by mass of carbon tetrachloride. Carbon tetrachloride formula is CCl4. And to calculate mole fraction, so mole fraction of benzene, so mole fraction is equal to number of moles of benzene, that is N of B, number of moles of benzene, N of benzene I am writing here, by N of benzene plus N of CCl4. Plus N of CCl4. And they have given expression 30%. So definitely 70% will be the benzene percentage. So percentage they have given. So you can substitute the formula. 70% will be benzene and 30% by mass of CCl4. So we can say number of moles of benzene, number of moles of CCl4, 70 by 70 plus 30. So just I am doing it here. 70 by 70 plus 30. 70 by 100 is equal to 0.7. 70 by 100 equal to 0.7. So let us see the hint. I think number of moles of benzene, you should take it as mass as well as molecular weight. So let us see now how we will get the question answer. So 0. Number of moles of benzene by number of moles of solute plus number of moles. So 0.822 it represents means nothing but should not take directly 70% here. So 70 grams of benzene should be taken. So benzene means 70 by 78. Number of moles of benzene becomes 70 by 78. 70 by, because molecular mass of benzene is 78. So 70 by 78, 0.89. Number of moles of benzene. Here you write number of moles of benzene is equal to 70 by 78, which is equal to 0.89. And number of moles of CCl4. Carbon tetrachloride 12 plus Cl4, 35.5 into 4, 1 second, 35.5 into 4 is equal to 142 plus 12 is equal to 154. So molecular mass of CCl4 is 154. That is 30 by 154 is equal to 0.194. So 0.19 you can take directly, no need of taking 4 again, just 2 decimals nearby. Now you can apply the formula N of B. So mole fraction of benzene is equal to N of B is equal to, so mole fraction of benzene, here I am writing mole fraction of benzene, that is 0.89. So 0.89 by 0.89 plus 0.19, so which is equal to 1.08. So 0.89 by 1.08, 0.89 divided by 1.08, get it as 0.822. So now it is clear. So in this way you have to do, because they are not given weight, so straight away we have to take mass percentage, that is 70 by 78, 30 by 154. I hope this is clear now. Next question. Calculate the mass of sucrose required to prepare 500 cc of 0.025 molarity of solution. They have given molarity here and mass of sucrose to be prepared, and volume is also given. So this should be taken as X and volume. So sucrose formula is C12H22O11, C12H22O11, H22, C12H22O11. So that is 12 into 12, 144, 12 into 12 plus 22 into 1, 144 plus 22 plus oxygen 16 to 11. 16 to 11 means 11 16s are 11. 16 to 11. 342. Total it comes around 342. So after adding everything, you will get 342. Sucrose. Again, I'm doing it here. So 12 12s are 144. So 12 12s are 144 plus 22 plus 176 is equal to 342. So this is the molecular mass of sucrose, and volume is given 500 ml. Now molarity, M is equal to weight of solute, that is mass of sucrose, M by molecular weight of sucrose, 342, into 1000 by V, 1000 on the numerator. Mass of sucrose, M by molecular weight of sucrose, 342, into 1000 on the numerator, divided by volume is 500. So simply if you do, you'll get M value, and here M is equal to given 0.025. So 0.025 is equal to molecular mass of sucrose we have to find out. So 2 into 171 into 0.025. 171 into 0.025. Which is coming around 4.275. Yes, 4.275 grams is the answer. Next question. Calculate molality, and mole fraction of a solute of potassium iodide if the density of 20% weight by volume. Solution is 1.202 grams per cc. Here they are given density as well as mass percentage. So before going to do this, I'll do this problem after giving one more formula. and that is the next session, the same session only, next slide. So, or else you can write here the formula. Molarity is equal to 10 into X into D by gram molecular weight. So gram molecular weight of potassium iodide. So you have to use this formula for finding molarity, capital M. And next we have relation between, first formula is this, second formula writing how to get molarity from molarity. Small m is equal to relation between molarity and molarity, m into capital M into 1000 by 1000 D minus capital M, that is molarity, into gram molecular weight of the solute. So these two formulas. And how to find mole fraction from molality or molarity. Mole fraction is equal to m by small m, that is molality by molality. Molality is small m only again, plus 1000 by molecular weight of potassium iodide, gram molecular weight, GMW. So if you use these three formulas, you'll get straight away the answer. First, we'll find molarity by using density and mass percentage. Then you can find molarity. Now, one by one, I will find it here. You can just see molarity is equal to molarity capital M is equal to first one. First I'm writing here 1. Molarity is equal to 10 into percentage is how much? X is how much here? 20% into density is given 1.202 and molecular weight of potassium iodide. I'm telling now potassium is 39. So molecular weight of potassium iodide is 166. Molecular weight of potassium iodide is 166. So if you do this calculation now, 10 into 20 into 1.02, I'm doing numerator multiplication, 10 into 20 into 1.202, which is equal to 240.0, 240.4 divided by 166 divided by 166. It is coming around 1.44. So molarity is equal to 1.44. Similarly, you can find mole fraction. So molarity, small m next. So small m is equal to second one. Use this formula for finding small m, and then you can find mole fraction of that is solution. So I hope this is clear. Now let us see the answers. 0.026 we got, 1.507, 1.45. So they have given molality first, molarity second, 1.507, which we got the same thing approximately, and third one we have mole fraction 1.45. So 1.45 is mole fraction. So you can check the answers by using the same formulas what I have given. So that is most important. Next, a solution of glucose in water is labeled as 10% weight by weight. Mass percentage they have given. What is the molality and mole fraction of glucose in the solution? If the density of the solution is 1.2 grams per cc, what would be its molarity? So again, they have given density and they are asking molarity also, same formulas. So first find molarity capital M. From that we can find molarity. So capital M is equal to 10 into X into D by gram molecular weight. So here it is glucose, so gram molecular weight. Next, same formula. Glucose weight is 180. So you'll get the answers. Similarly, next what they are given, From molarity, you can find mole fraction. Sorry, molality. Molality is equal to molarity into 1000 by molarity into 1000 by 1000 into D minus molarity into gram molecular weight. Molarity into gram molecular weight of the solute. That is 180. And finally, mole fraction is equal to m by m plus 55.5 because this is aqueous solution they are given. Glucose in water. So aqueous means 1000 by 18. That is 55.5. 55.5. So I hope this is clear now. By applying these formulas, definitely you'll get the values. Next question. So you got the values. You can check the answers. Next, we have more questions based on interconversions of concentrations. Interconversions of concentrations. Very, very important. Definitely you'll get questions based on this. Interconversions of concentrations. So molality into molality already I have given you. So simple again, you can use this formula also. Molarity by density minus molarity into molecular weight. M2 is called molar mass of solute. So use these formulas in the previous questions also, you'll get the same thing. Next, molarity into molality. That is molality is equal to capital M. Here I'm writing. You also just note down. It's very, very important. So molarity is equal to capital M, that is molarity by density minus molarity into mass of solute, gram molecule. Here 1000 I kept, here 1000 it's not required. So even if you keep also, that is also same thing you will get. This is another formula, this is short formula we have given here. Next we have, next slide. So next slide, 1 second. So molarity small m is equal to, again, just note it down. Small m is equal to interconversions of expressions for concentration. Capital M. Capital M is called what? Molarity. And next we have density. Rho is called density. That is D or rho, you can write, minus molarity again into gram molecular weight. That is gram molecular weight of solute. That is molar mass of solute. So I hope it is clear now. Now second interconversion. Molarity into mole fraction. Straight away you can use these formulas. So molarity is equal to X2P. X2 is called what? Mole fraction of solute into density by X1, that is mole fraction of solvent, into molarity, that is molar mass of solvent, plus X2 into molar mass of solute. So M2 is called molar mass of solute, M1 is called molar mass of solvent, M is called molarity of the solution. So M is called molarity of the solution. So M is equal to this. In this way you can find, once you know molarity or molality or mole fraction, you can find the other two easily. I hope this is clear. Now we'll see molality into mole fraction. So this formula also I have given one formula, x by x plus 1000 by 18. That is also same. Here also you'll get the same thing. So that is molality is equal to x2 by x1 into m1. X2 by x1 into m1. Where x2 is called mole fraction of solvent. That is number of moles of solvent by total number of moles of solution. And x2 is called mole fraction of solute. And m1 is called molar mass of solvent. So this is clear now. Now we'll see questions based on this. Calculate the molarity of 1 liter solution of 93% H2SO4. 93% they are given here again. H2SO4 weight by volume. The density of solution is. So 1 liter solution of 93% H2SO4. So they are giving, first we have to find molarity. From that you can find molarity. First you have to find molarity. From that you have to find molarity. And they are given weight by volume percentage, 93% of sulfuric acid. So 93% of sulfuric acid. From this you can find capital M, molarity. After finding molarity, you can find small m. So let us see how to find it. First, capital M is equal to 93% weight by volume, means 93 grams of sulfuric acid. 93 grams of sulfuric acid dissolved in 100 ml of solution. Dissolved in 100 ml of solution. 93 grams dissolved in 100 ml of solution. So that is the meaning of weight by volume percentage. So 93 grams of sulfuric acid. So we can write molarity is equal to mass of sulfuric acid, that is mass of sulfuric acid 93 by gram molecular weight of sulfuric acid, that is 98, into 1000 by 100, because volume is given 100 ml, 93%. So it is 10 times. So 93 into 10 by 98, 930 by 98, 930 divided by 98, which is coming out 24.4. 930, 93 to 10, that is 930 divided by 98, which is equal to 9.4. 9.48 is the molarity value. Now substituting this molarity value in molality. Molality is equal to molarity by capital M by D, that is density, minus molarity into gram molecular weight of solute. Molarity into gram molecular weight of solute. So substituting this, solute is 90 and sulfuric acid, and it is 98. So 98 molecular weight of sulfuric acid is 98. Now molarity is equal to, we already got, that is 9.48 by density, that is given 1.84 minus 9.48 into 98, because molecular weight of sulfuric acid is 9.48 into 98. First let us see 9.48 into 98. Is equal to 929.04. So you'll get the answer directly. Now after substituting this, you'll get the answer. Molarity is equal to 1.043 molarity. Next question. Glauber salt. So 8.0575 in 10 to the power minus 2 kg of Glauber salt is dissolved in water to obtain 1 decimeter cube of solution. That is 1 liter of solution of density 1.7. Here also density is given, weight of Glauber salt is given, and calculate the molarity and mole fraction of sodium sulfate in the solution. So Glauber salt means here sodium sulfate, hydrated sodium sulfate. So Glauber salt, I'm writing the formula. You can just write Glauber salt is hydrated sodium sulfate, that is equal to decahydrate sodium sulfate decahydrate Na2SO4 10H2O. Na2SO4 Na2SO4 dot 10H2O. So molecular mass, if you calculate, you can see here sodium 23 into 246 plus sulfur is 32 plus 64 oxygen plus 10 into 18 180. So it is coming out 322. Molecular mass of Glauber salt is 322. So that is molecular mass of Glauber salt, that is molecular weight. So here also they are given weight of solute dissolved in water to obtain 1 decimeter cube of volume is given, density is given, and calculate molarity. So you can use the formula molarity is equal to weight of solute, capital M. Molarity is equal to weight of solute by molecular weight of solute into 1 by V, because volume is given liters, so into 1 by V. So by using this formula, you'll get molarity. After getting molarity is equal to small m is equal to, I'm writing all the formulas, capital M by density, that is rho, minus M, that is molarity, capital M, into gram molecular weight of solute. In this you'll get molality, and next mole fraction is equal to M is equal to, for molality you can find mole fraction, molarity is equal to X2, that is mole fraction of solute by mole fraction of solvent into M1, that is molecular mass of solute. Molecular mass of solute. Molecular weight of solute. So by using these three formulas, definitely you'll get the answer. So I hope it is clear. Next. So answers are 0.25 molarity, 0.26 molality, and X is equal to 0.0046. That is mole fraction of solute. Next. Mole fraction of solute in aqueous solution of sodium hydroxide is 0.1. Then the molality of the solution is. So they have given mole fraction of solute in aqueous solution of sodium hydroxide is 0.1. Then molality of the solution. So the relation between mole fraction and molality is equal to X is equal to M by M plus 55.5, because this is aqueous solution. So 55.5 directly. So 0.1 is equal to X by X plus 55.5. X by X plus 55.5. The molality is equal to X. For understanding. 55.5, how you got? 1000 by 18. Because since it is aqueous solution, we have to take 1000 by 18. Straight away you'll get 55.5. This is a short form. This formula please write down. For aqueous solution it is applicable. So 55.5. Not solving, you can do it now. So I'm not solving here. So this is the formula, and after solving this you will get the value of X easily. I hope it is clear now. So the answer will be, you can check the answer. After solving, it should be equal to 0.002. Next question. Calculate the molarity of 10% weight by volume of sodium hydroxide solution of specific gravity. Specific gravity they have given 1.10. When they are given specific gravity, you have to write the formula. 2 into vapor density is equal to specific gravity. So you can see here now backside I'm showing the formula so that easily you can apply. You can see the formula and do it. This is for your working I'm giving. I'm not explaining this. So I should get is 2.5 molarity. Next, example 5. Density is given 10% weight by weight solution. Molarity you have to find. So weight by weight means you can find from weight by weight, you can find molality first. Write down here. 10% weight by weight means 10 grams is dissolved in 90 grams. So total 100 grams of solution. So 10% weight by weight means here they are given mass percentage. From mass percentage you can find small m. And from small m you can find molality, capital M. So how to find molality from small m? So small m is equal to capital M by D minus, that is density, minus M into gram molecular weight of solute. The solute is sodium hydroxide. So use these two formulas. How to find from weight percentage by molarity? So weight means 10% of sodium hydroxide means here 10 grams of sodium hydroxide. 10 grams of sodium hydroxide dissolved in 90 grams of solution. Dissolved in 90 grams of solution. Dissolved in 90 grams of solution. So first you can find small m. So small m is equal to, I'm doing it here down. Small m is equal to weight of solute, that is 10, by weight of gram molecular weight of solute, that is 40, because sodium hydroxide is 40, into top 1000 by weight of solvent, that is 90 grams. How we got 90? Because 10%. So after solving this, you'll get the answer for molarity. Once you got molarity, you can find out molarity. So after solving molarity, you'll get molarity. Here directly molarity answer is given, that is 2.something molarity. Next. Example 6. That is 250 ml of sodium carbonate solution contains 2.65 grams of sodium carbonate. 10 ml of this is added to X ml of water to obtain 0.001 molarity solution. Find the value of X. Very, very important. So 250 ml of sodium carbonate solution contains 2.65 grams of sodium carbonate. So they have given volume as well as weight of sodium carbonate. So 10 ml of this is added to XML of water to obtain 0.001 molarity solution. Find the value of X. So first we will find molarity. Here you have two solutions. First we know 250 ml of sodium carbonate. From this we can find molarity 1, and next we have to find molarity 2. Molarity 2 is given volume. So M1V1 is equal to M2V2. Use the formula M1V1 is equal to M2V2 here because these two solutions are there. So first solution is sodium carbonate solution containing 2.65 grams and 250 ml. So first we will solve for M1. Then V1 already you know, V2 you know 10 ml, and V2 we have to find. Next we have to find M2. So first we will see M1. So how to find M1? M1 is equal to, that is molarity 1, M1 is equal to weight of solute, that is 2.65, by molecular weight of sodium carbonate 106 into 250 ml. Sorry, 1000 by 250. 1000 by 250. So that is 250 ones are 254s are. So 2.65 into 4, 10.6 by 106. 10.6 divided by 106 is equal to 0.1. So molarity of first molarity is 0.1 molarity. Now second molarity is already 0.001. Now what is they asking? M2 is equal to how much? M2 is already given 0.001. So now M1 V1. So M1 is 0.1 is equal to M2 V2. So first M1 is equal to 0.1 already we got. So 0.1 into, here very important, 10 ml of this solution. So V1 should be taken as 10 ml, not 250 ml. V1 should be taken as 10 ml. 10 is equal to M2 is already given 0.001, 0.001, and X you have to find out. That is V2. So you'll get the answer. I hope this is clear now. 0.1 into 10 is 1. 1 is equal to 0.01 into X. So X will be 1 by 0.001. 1 divided by 0.001, which is equal to 1000 ml. So I hope this is clear now. We'll see 990 ml because 10 ml of this added, no. So 1000 minus 10, it will become 990. So 990 ml. I hope this is clear now. So I'm ending this session. So today we have done many examples based on concentration of solutions. So all these examples are most important. And next class, next session, we'll do more about solutions. I hope this is clear for you. Thank you.